Welcome to the video lecture on the course of AMP and Linear Integrated Circuit. In this session, we will be discussing the basics of the phase lock loop PLL system. So in the previous session, we have seen the operating principle of a phase lock loop. In this session, we will be seeing the three different states of a phase lock loop, how the operation is going to occur, and what are these three different states of a PLL system. So a PLL goes to three different states, what we can say. So taking the part here, initially when we apply when a signal is not given to the phase detector, that is there are no signals applied to the phase detector, input signals applied to the phase detector, the phase detector output will be equal to 0. If the phase detector output equal to 0, the oscillator oscillates around its own frequency. We call it as a free running frequency there. So free running frequency, that is a free running state, what we can say, free running state. And now when an input is applied to the phase detector, so there might be changes. The phase PLL is nothing but we want the input frequency to be equal to output frequency. So that is the entire picture, what we can say, of a phase lock loop. So now when input is applied to the phase detector, there is an error voltage. Now that error voltage is applied to the voltage controlled oscillator and it converts it to that particular frequency. So these two frequencies are compared now. So now it comes out of free running state and it goes into the tracking state or capturing stage, what we can say. It is a capturing. So the output is going to capture with the input part. Input we have applied, but it has not reached the output part. So output is going to capture, that is a capturing range. And once after that is done, when both signals frequencies are going to be equal, they will be locked at that particular part. So which indicates that output, it says that, oh, my frequency has reached there, so f0 is equal to fi. When f0 is equal to fi, there is a lock between that, and that is the lock state, what we can say. So we will see this part, the free running state, the capture range, and the phase lock, what we call it as a lock range. So we will see the definitions of this and then move on. What is a lock range? When PLL is in lock, it can track frequency changes in the incoming signal. So PLL is in the lock condition, that is output frequency is equal to input frequency, or we can say Fi is equal to F0. But the phase detector work is to check whether there are changes in the input signal still occurring. F0 is equal to Fi. It will not check for F0. It will check for the input signal changes. The range of frequencies over which PLL can maintain lock with the incoming signal is called the lock range or the tracking range of the PLL, or the tracking range of PLL, what we can say. This is about the one part, that is the lock range. Now the second one is the capture. The range of frequencies over which PLL can acquire a lock with an input signal is called the capture range. So there are a set of frequencies. So whether it can be a maximum value or a minimum value. Between these two maximum and minimum values, there are range of frequencies over which PLL can acquire a lock with the input signal is called the capture range. And the next one is the pull-in time. The capture of an input signal does not take place as soon as the signal is applied, as I have termed. Initially we apply the input, so there will be no lock condition occurring, but it takes finite time. The total time taken by the PLL to establish a lock is called the pull-in time. So these are three different parameters or three different states where the PLL is mainly working: the free running state, the capture state, and the lock state. So thank you for watching this particular session.